Welcome to Rges Algebra 2. This is lesson 3.3. We're continuing with other forms of the linear function equation. Now, we have talked already about one form of a linear equation, and that is what we call the slope-intercept form. It looks like y, solve for y on the left-hand side, equals mx plus b. We talked about that fairly extensively last time, and recall m is our slope, and b is the y-intercept, where the line crosses the y-axis. We can see why it would be called the slope-intercept form, because if we get it in this form, we can read off the slope and the y-intercept very easily. Now, a second form would be what we call the point slope form. And the point slope form looks like this. Y minus y1, y1 would be a number, okay, equals m, that would be slope, x minus x1, and that would be a number. So what we're getting here is we're going to be able to quickly read off a slope and an x and a y. So the x and the y would represent a point, and m would represent the slope. And I'm trusting that you understand that if I have any point, like where it crosses the y-axis, and I know the slope, the run and the rise, then I can have a line. On the other hand, if I have any point not on the y-intercept, just any point that contains the line, or that the line contains, and I know from there the slope, the run, and the rise, then I can also identify the line. And that's what we're talking about here. So the second one, which is the point slope form, would look like something like this. Y minus 5 equals negative 3/2 x plus 1. And I can read off of this, this would be my slope, my slope, or m, equals negative 3/2, and my y and my x can be read off also. Always take the negative value. So my x would not be a positive 1, but a negative 1. My y would not be a negative 5, but the opposite sign, the positive 5. Okay, so there's my point. There's my slope, and if I wanted to graph that, all I would have to do is graph the point, negative 1, 5, somewhere up like this, and then I would go run over 2, down 3, whatever that would be, okay? I'm just kind of eyeballing it here, and my line would look like that. Now my third form of the linear equation would be what we call the general form. At least that's the way I learned it. Let's see. I'm trying to see if they have a different. They just say the ax plus by plus c, or I'm sorry, equals c form. Okay, so that's fine. Okay, now these would be, a, b, and c would represent integers, okay, integer constants. So let's look at the problem here. It says example 1 on page 83, I've actually done the first part for you. It gives you y minus 5 equals minus 3 halves x plus 1. I recognize that as my point slope form of the equation. I plot the graph quickly, which I showed you exactly how you would do. You would identify the point -1, opposite signs 5, plot that point on the line on the graph, okay, and then you would move from there over and down to plot a second point and graph your line. It says transform it. B, transform the equation to slope-intercept form. Well, recall slope-intercept form, what I need is something that says y equals mx plus b. So I want to solve this equation where it just looks like y equals. Well, first I'll distribute that, and I'll say y minus 5 equals negative 3 halves x minus 3 halves. And then I would add 5 to both sides. 5 is the same as 10 halves, right? So it looks like I'll need that. So if I do that, I'll have y by itself. I'm adding a constant, so I'm going to have to join it to the second one, not to the x value. So that will remain the same. And now I've got minus 3 halves plus 10 halves, or plus 7 halves. And now does this look like the slope-intercept form? It should. I've got the slope there and the intercept there. Now C, part C says transform the equation to the ax plus by equals c form, where a, b, and c are constants. So you can go ahead and start with the one you have in B. That's actually probably a little easier. I want the x, I want the y on the left side, the x on the left side, and the constant on the right side. So here, to get this the x term to the left side, I would add 3 halves, so I would get y plus 3 halves x equals 7 halves. So far, so good. I've got the y on the left side, the x on the left side, and the constant on the right side. But what I need is to have it all in integers. So I would need to get rid of my fractions by multiplying everything on the left and the right by 2 in this case. So I would go ahead and get 2y plus 3x equals 7. You see how that works? Because when I multiply by 2 and I'm multiplying my x term, the 2's cancel out and I'm left with a integer 3x. When I'm multiplying the constant on the right side, the 2's cancel out and I'm left with the integer y. Now that we're almost there, we want, by convention, the x term to go first, so we would write 3x plus 2y equals 7. Next, I'd like to do the problems on the top of 3.3, page 85, the ones they ask you Q1 through Q10 to do quickly. So if you will grab your book, let's talk about each of these very quickly, and then you can do it on your own, or you can do it on your own and then watch for review. Q1, sketch a graph in which y increases as x increases. Well, if we're talking about they increase to the same amount, if we have 1 on the y, we'd have, or 1 on the x, we'd have 1 on the y. If we have 2 on the x, we would have 2 on the y, and etc. We would have a line that goes up straight in that direction, and probably also down in that direction also. Simplify. 3 plus 2x minus 5. We're going to, I should say, times plus 2 times the quantity, x minus 5. We're going to distribute that 2, and we're going to end up with 2x minus 10 plus the 3 we have before, or 2x minus 7. This will be a FOIL on Q3. You have no troubles with that. This to solve for Q4, you would have to add 7 to both sides, getting 2x, making 2x equals 38, and then divide by 2, making x equal 19. To evaluate it, we're going to plug in the 3, we're going to square it, so now it becomes 9, and 9 times 5 is 45. To do the next one, okay, we haven't, I don't think, quite done anything like this up till now. It says, what percent? Usually we've been asking for what is the percent, but, or what is 30% of something, for instance. This, we're switching it a little. We say, what percent of 40 is 12? So if we have 12 over 40, what is that as a percent? So I want to know, what is that over 100? And so that would be the way that sets up. To cross multiply, we would get 40x equals 1200, and to divide by 40, you would get x equals 30. Now make sure that makes sense to me. Is if I'm asking what is 30% of 40, well, 10% of 40 is 4, 30% is 12. Well, that does indeed make sense. Okay. 7, when I say x equals x, for all real numbers, that is the reflexive property. Evaluate. Careful, what do you have to remember for Q8? Tricky, because you messed it up before on the quiz. Square root of 49 has 2 answers, plus or minus. We can write it that way, plus or minus 7. Make sure you remember that. Multiply. To multiply fractions, we simply cancel and multiply straight across. So if I had 2/3 times 3/4, my 3's cancel out, my 2 goes into 4, 2 times, and my answer is 1/2. Factor. Fairly straightforward factoring problem. We're looking for 2 numbers multiplied together to give x. We're looking for 2 numbers multiplied together, multiplied together to give x squared. 2 numbers multiplied together to give me 5, and if I add them I get 4. That would be a 5 and a 1. I need a positive 4 when I'm done, so I'll put the plus there and the minus there. And hopefully you recall that from previous years. Okay, so I think the rest of it will be straightforward for you. Bring any questions to class.